The purpose of this exercise is to teach you how to use the tools in Excel to conduct an ANOVA. The problem in the textbook states that Company S, the accounting firm, has an HR department that has suggested managers learn different leadership styles to help decrease employee stress levels. An experiment was conducted to determine if leadership styles, transformational and transactional, in management significantly impacted employee stress levels compared to no intervention. An employee survey was given to 3 groups. One group under a manager who started using a transformational motivation technique, one group under a manager who began using a transactional motivation technique, and then a control group with no new technique being used. Stress levels were self-reported by the employees as shown in Table 9.2. We are to use an alpha level of 0.05 for our test. The first thing we need to do is enter the data into Excel from Table 9.2 as I've done here. Next, we'll need to run our ANOVA. To do that, we go up to the Data ribbon and click Data Analysis. From the list, we choose ANOVA single factor because we only have one factor being explored here, and that's the management style. Our input range will be all of the data in Excel. And we must indicate that there are labels for each column in the first row, and that we would like the output to appear in a new worksheet ply. Once we have entered all of our information, we can click OK. And a new worksheet ply opens up with all the necessary output for our ANOVA. The first thing that is presented are the summary statistics for each of the groups. So for the different management styles and control groups, we can see the number of participants in each group, as well as the average stress level and the variance for each group. The second table provides our ANOVA statistics. So this is where we will need to look to determine if there are statistically significant differences in stress levels across the different groups in the experiment. We can see that our F value is 5.43 and our P value is 0.02. This falls below our alpha value of 0.05, so we can determine that there are indeed significant differences in the level of reported stress between groups. But we do not yet know exactly which groups differ in their stress. We only know that there are some differences in the data. In order to better understand which groups statistically differ in terms of their average stress level, we would need to conduct what's called a post hoc test. In Excel, there are not good features to conduct post hoc tests, so we have to rely on other methods. One way, however not ideal, is to run a t-test between the 2 groups you wish to test, so that you can figure out if there is a statistical difference between those 2 groups. And this is not an ideal way to test for group differences, because it inflates our chance of type 1 error, or finding significance where there truly is none. This risk becomes greater when there are multiple groups to be compared, because we are bound to find a significant difference between groups just by chance, rather than there actually being a true difference between groups, hence inflating our risk of a type 1 error. Therefore, using an alpha value of 0.05 is too liberal of a value and may result in type 1 error. If we must use t-tests to look at differences between groups, we can adjust our alpha value to a more conservative level to reduce our chances of type 1 error. We can do this by performing a Bonferroni adjustment. To test the differences between groups, we will need to go back to the worksheet ply where the original data are entered. In order to apply a Bonferroni adjustment, we must first determine how many comparisons we will need to do between groups. In this example, there are 3 different comparisons that we would want to do. The difference between transformational and transactional, the difference between transformational and the control group, and the difference between transactional and the control group. So there are 3 different comparisons we will need to do. So our Bonferroni adjustment will be equal to our original alpha value, 0.05, divided by the number of comparisons that need to be made. So our new alpha value for determining significance is 0.017. So in order to be significant, the p-value for the t-test between groups will need to fall below this new value rather than the original 0.05. Now we can conduct t-tests for each of our comparisons. To conduct a t-test, we use the t-test function in Excel and select the arrays we will need to use. First, we will select the transformational data, followed by the transactional data. And we're going to choose a two-tailed distribution because we're not making any a priori or ahead of time assumptions about which way the difference falls. We just want to know whether or not there's a difference between groups, whether it's that transformational is higher than transactional or transactional is higher than transformational. If we had a clear idea about which one should be higher than the other, we could conduct a one-tailed distribution test, but for now we'll stick to a two-tailed test. And we want to choose either option 2 or 3 because these are independent groups, not paired samples. And if you remember from the hypothesis testing chapter, we must have first determined whether or not the variances between the groups are equal. In a conservative test, we will assume unequal variance, which we will do here using option 3. So our alpha or p-value for the difference between the transformational and transactional groups in terms of stress level reported by the employees is 0.4. And this is much, much larger than our Bonferroni adjusted p-value of 0.017, and it's also larger than our p-value of 0.05. So we can conclude that there is no statistical difference between these two groups in terms of stress level. Next, we will look at the difference between the transformational and the control group. This time we will select the data for transformational for array 1 and the data for control for array 2 and use the same options as before. This time we get a p-value of 0.06, which is not significant given our adjusted alpha level or even our original alpha level of 0.05. So there is no statistical difference between the transformational and control groups. Last, we will look at the difference between the transactional and control group. The p-value for the difference between the transactional and control groups is 0.0059. This falls well below our Bonferroni adjusted alpha level of 0.017, so we can conclude that there is a statistical difference between the transactional and control groups in regard to employee-reported stress level. So although our overall ANOVA suggested that there were differences in stress levels between groups, the only statistically significant difference between groups was between the transactional versus control groups. And we were not able to tell this until doing post hoc analyses, which again are not easy to do in Excel. So we instead did simple t-tests between all three groups using a Bonferroni adjustment to reduce our chances of type 1 error. And that is how you can use the tools in Excel to conduct an ANOVA.